There is something about the moon landing that has always stayed in my mind, something that still makes me stop and think no matter how many years pass, because the more you look at the science behind it, the more you understand how close it was to being impossible, and the more you realize how brave and skilled the people involved had to be to pull it off. I first watched the moon landing as a child on a small television, not knowing anything about rockets, physics, or engineering, but even then I felt there was something strange about seeing humans stand on a place that was not Earth. As I grew older and studied science, the feeling only became stronger. It was not doubt. It was respect. Because when you look closely, the moon landing becomes one of the hardest things humans have ever done, something so full of danger and challenge that it feels like we should not have been able to do it in the 1960s. To start with, the computers were shockingly weak. The Apollo guidance computer had less memory than a cheap watch today. Your phone could outthink that computer a billion times over. Yet that tiny machine had to help guide a spacecraft across hundreds of thousands of miles, through a path shaped by Earth's gravity, the moon's gravity, and the spacecraft's own motion. Space is not still. Everything is moving. The path to the moon is not a straight line, it is a curve inside a system that never stops shifting. This is what physicists call the three-body problem, and even with modern supercomputers it is not easy. But NASA scientists solved it with pencil, paper, and a computer that could barely do basic math. When you think about that, the moon landing suddenly feels even more unreal. But the computer was only the first challenge. The second was radiation. Between Earth and the moon, astronauts pass through the Van Allen radiation belts, a region filled with charged particles that can damage electronics and harm the human body. Today, space agencies treat radiation as one of the biggest dangers for long missions. Engineers talk about thick shields, storm shelters, and safe zones. But the Apollo spacecraft had thin metal walls. The astronauts had no heavy protection. They passed through the belts quickly to limit exposure, but it was still a risk that would never be accepted today. And once the astronauts reached the moon, new problems began. The moon has no air, no clouds, no wind, nothing to soften the sun's heat or soften the cold of its night. In the daytime, the surface becomes hotter than boiling water. At night, it becomes far colder than any place on Earth. A human cannot survive even a moment in those temperatures. The suits built for the astronauts had to handle both extremes with a simple water loop inside the suit to carry heat away from the body. This was in the 1960s, long before small, powerful cooling systems existed. Yet the suits worked. They protected the astronauts as they moved and worked in a world that wanted to freeze them or cook them. Then comes the lunar module itself, a strange, thin machine that looked like it could fall apart if you touched it the wrong way. It was wrapped in gold-colored foil and built with walls as thin as a soda can. But this was by design. Weight was the enemy. Every extra gram needed fuel, and fuel was the limit that could not be broken. The lunar module did not need to survive strong winds or heavy hits. It only needed to keep working in space and on the moon. Still, when you see photos of it today, it looks like something that should never have been able to carry two humans safely to the surface of another world. And yet it did. And that landing was not smooth. When Armstrong looked out of the window and saw that the computer was guiding them toward a field of big rocks, he took control himself. The clock was ticking. The fuel was draining. The landing area was not safe. He moved the craft forward, searching for flat ground, while warnings sounded in the system. When he finally landed, there were only seconds of fuel left. A moment longer, and the lunar module would have crashed. When you place all these details together, weak computers, dangerous radiation, thin spacecraft, extreme temperatures, and a landing with almost no fuel left, you begin to see why the moon landing is one of the most impressive acts in human history. It was not easy. It was not simple. It was not guaranteed. It was a moment when humans reached far beyond what seemed possible. And that is why people still talk about it, still feel amazed by it, and still ask questions about how such a huge mission succeeded with such limited tools. When people ask why we have not returned to the moon in more than 50 years, they often hear answers about cost and politics, but the deeper truth is that the moon landing required a mix of focus, money, teamwork, and risk-taking that we simply have not seen again since that time. One way to understand this is by learning about the rocket equation. Rockets are nothing like planes or cars. A car can stop for gas. A plane can glide if its engines fail. But a rocket must carry all of its fuel from the start, and the more fuel it carries, the more fuel it needs just to lift the fuel. This creates an endless cycle where weight becomes the biggest enemy. Even a small change can ruin the entire mission. The Saturn V rocket was one of the most powerful machines ever made, taller than a skyscraper, burning fuel at a rate that sounds almost impossible, and creating a force strong enough to throw humans out of Earth's gravity. And here is the surprising part: even today, we cannot simply rebuild it. The factories that made its parts are gone. The engineers who designed it have retired or passed away. Some of the blueprints are missing. Many of the tools used to shape its metal were destroyed long ago. People talk about tacit knowledge, the kind of skill you cannot write in a book, the kind that workers learn through years of building and testing. That knowledge faded when the program ended. This is why rebuilding Saturn V today would be like trying to rebuild a huge ancient ship using only pictures and memories. And then there was the software. The Apollo computer had to make fast decisions during the landing, and when it became overloaded during Apollo 11, it did not freeze or shut down. It simply ignored tasks it did not need and kept the landing system running. This design was simple but strong, and modern computers, with their complex software, often behave differently. They freeze. They restart. They crash. Apollo avoided that by keeping things as simple as possible. Another question people often ask is how the astronauts took such clear photos on the moon. They had big gloves on. They could not see through the camera. There were no screens to check the picture. They had to trust their training and trust the camera, which had been modified for space. Thousands of photos came out almost perfectly exposed. But this was not luck. The lighting on the moon does not change like lighting on Earth. There is no air to scatter light. Shadows are sharp. The sun is bright. Once you know the settings, the camera will capture sharp images again and again. The film shows tiny marks left by cosmic rays, proving it was exposed to deep space. And the shadows match the direction of the sun exactly as physics predicts. Still, the photos add another layer of wonder. They look so clean and so sharp that people sometimes think they look too good, but this is because the moon has simpler lighting than Earth, not because something strange happened. We also cannot forget Apollo 13, the mission that nearly ended in disaster. No one would fake something like that. No one would pretend a tank exploded and then spend days trying to save 3 astronauts. But the world heard the fear in the astronauts' voices and saw the real struggle on the ground. Those were real problems, real physics, real engineering, and real risk. If anything proves Apollo was real, it is Apollo 13. When we look at why we have not gone back, the answer becomes simple. Apollo happened at a time when the world was focused, when money was no object, and when people were willing to take risks that modern programs cannot take. Today, we have better computers, better materials, and better technology, but we also have stricter rules, more cost control, and less freedom to take huge risks. The moon landing happened because everyone involved moved in one direction with full force. It was the perfect mix of science, courage, and national pressure. Without that mix, it is hard to repeat such a huge achievement. But now, for the first time in decades, humans are getting ready to return with the Artemis program. NASA is building new rockets, private companies are creating cheaper and more powerful designs, and nations around the world are paying attention to space again. The dream of returning to the moon is real, but the difficulty is still there, waiting. As we look toward the future, the moon becomes more than a destination. It becomes a starting point for the next steps in human exploration, because going back is not only about repeating what was done before, but about learning how to live and work on another world for longer periods of time. When humans return, they will not stay for just a few days. They will build camps, test new machines, gather resources from the surface, and prepare for missions deeper into space. One of the biggest goals is to learn how to use the ice trapped in the moon's shadowed craters. This ice can be turned into water to drink, oxygen to breathe, and even fuel for rockets. If humans can learn to use the moon's resources, then missions to Mars become far easier, because rockets would not need to carry all their fuel from Earth. But the moon will also test our limits. The dust is sharp and gets everywhere. The radiation is stronger than what astronauts experience on the International Space Station. The low gravity may cause long-term health problems. These challenges remind us that space is not friendly, and that everything humans do off Earth requires planning and protection. But solving these problems is part of what makes space exploration special. Every issue we face pushes technology forward. Every barrier we cross opens the door to new discoveries. And the moon is just the first step. Beyond the moon lies Mars, a world that has captured human imagination for generations. Mars is far harder to reach. The trip takes months. Communication is delayed. The weather is severe. The atmosphere is thin. Landing a heavy craft on Mars is one of the hardest engineering problems in space, because the atmosphere is too thin to slow the ship like Earth, but too thick to ignore like the moon. Even with all this, humans want to go, because Mars may hold answers about life, climate, and the history of planets. A human mission to Mars will require everything we learned from Apollo and everything we will learn from Artemis. And beyond Mars lies an even bigger dream, one that scientists talk about when they study the future of civilizations. This is the idea of the Kardashev scale, which measures how advanced a species is by how much energy it can use. Humans today are at about 0.7 on this scale. A Type 1 civilization controls all the energy of its planet. A Type 2 uses the energy of its star. A Type 3 uses the energy of a whole galaxy. These levels may sound like science fiction, but so did the idea of humans walking on the moon to someone living a century ago. Every major step begins as an idea that feels too big. The moon landing was such a step. It proved that humans could leave Earth, survive the void of space, land on another world, and come home safe. It showed that impossible things become possible when enough people work together. It inspired new generations to study physics, build machines, and dream bigger. And it changed the way we see ourselves. When the astronauts looked back at Earth from the moon, they saw a small blue world surrounded by darkness. No borders. No divisions. No fights. Just one planet, one home, one species. That view helped people understand how fragile and precious Earth really is. It sparked new movements to protect the environment and care for our world. The moon landing did more than show us what we can do. It showed us what we could lose. As we prepare to return, we carry those lessons with us. We know space is hard. We know it is dangerous. But we also know that humans are explorers. We move forward. We learn. We reach. And every time we take a new step, we learn something about the universe and something about ourselves. The moon is not the limit. It is the beginning. One day, we will return to the moon. One day, we will walk on Mars. One day, we will travel farther than any person alive today can imagine. And when that day comes, the first footprints on the moon will be remembered as the moment when humans proved that even the hardest challenges can be overcome. The moon landing was not impossible. It was simply the point where the courage of humans met the laws of physics and refused to stop. And that spirit will carry us to places we have only dreamed of.